let us understand this very interesting concept, and that is electromagnetic induction. Now, what does electromagnetic induction mean? It means production of electricity from magnetism. This electromagnetic induction was discovered by the scientist Michael Faraday in the year 1931. Let us see how Sir Michael Faraday discovered, or what exactly is electromagnetic induction. For this, what we do is we take one bar magnet with a field around it. So I have this bar magnet which is surrounded by magnetic field lines. Also, I take this conductor. Now we know a conductor generally contains two things. Firstly, it contains atoms in a state of vibration, and secondly, it contains free electrons in random motion. Now, I take this particular conductor and I move it through the magnetic field. When I move it to the magnetic field, let us see what happens. Initially, right now, as we are looking, electrons are moving in random motion and hence there is no current. But as soon as this particular conductor is moved through the magnetic field, what will happen is the conductor cuts the lines of force. As lines of force are cut, these lines of force make the electrons move in one direction. And as electrons are flowing in one direction, current is induced. And this is how electric current is produced from magnetism. Going further, students, let us perform an activity to understand electromagnetic induction more in detail. So what we do is, a wire is coiled on an insulator. After coiling a wire on an insulator, next you take a galvanometer which is connected in series. What does a galvanometer do? It shows current and it also shows direction of current. Next, you take one bar magnet, and this particular a strong bar magnet with its north pole is moved towards the coil. Now, when I move this strong bar magnet towards the coil, what do you observe? You observe the galvanometer needle is deflecting to the right, thereby showing that current is being produced. But as soon as the conductor or the bar magnet is stopped, the deflection drops to zero when motion of the bar magnet is stopped. That means current is being produced as long as the bar magnet is in motion. Now, what I do next is move the south pole towards the coil. Now, when I move the south pole towards the coil and once again move this bar magnet to the field, you can observe that galvanometer deflects to the left. That means now the direction of current has changed. So deflection becomes zero, the motion is stopped once again. That means the current is being produced as long as the bar magnet is in motion. So students, thus current has been produced due to magnetism, and this is called as electromagnetic induction. Now, by definition, let us see how we define electromagnetic induction. It is defined as the process by which an electric current is induced in a conductor due to the change in magnetic field is called electromagnetic induction. Also, we have the following conclusions from this activity. We conclude that first thing, motion of the magnet with respect to the coil produces an induced potential difference which sets up an induced electric current in the circuit. The second thing we understand, the direction of induced current depends on two things. First, it depends on direction of motion of the conductor, and second, it depends on direction of magnetic field. After understanding this, the question generally arises, students. From the last experiment, we conclude that motion of magnet with respect to coil produces the current. Hence, students, direction of motion of coil and direction of induced current are interdependent, and this can be found by a rule, and this rule is called as Fleming's right hand rule. For Fleming's right hand rule, what you do is you stretch three fingers, the thumb, the forefinger and the central finger of the right hand mutually perpendicular to each other, as you can see in the diagram. Now if you stretch the thumb, the forefinger and the central finger mutually perpendicular, and if the thumb shows the direction of motion of the conductor and if the forefinger shows the direction of magnetic field, then the central finger will show the direction of the induced current. This, students, is Fleming's right hand rule. Let us put this in words and let us see how this is defined. So Fleming's right hand rule states, stretch the forefinger, the middle finger and the thumb of your right hand mutually perpendicular to each other. If the forefinger shows the direction of the field, the thumb shows the direction of motion of the conductor, then the middle finger shows the direction of induced current. So students, this was Fleming's right hand rule. Thank you.